So this question, a block of mass 2 kg is attached with two identical springs of spring constant. Here springs are there. So then you have to recollect from the topics you have studied. Maybe this is from oscillation or work per energy. Okay. The block is placed on the frictionless surface and the ends of the springs are attached to the supports when the mass is displaced from its equilibrium position. Equilibrium position. Equilibrium in the sense what we have to say is that forces are equal. Which force? Spring force will be equal to the other force, that is restoring force. I mean TA. It exerts a simple harmonic. Here the hint is there. Simple harmonic motion. So this is from SHM chapter, that is oscillation chapter. Now we have to find out the time period. So what we know is that to find out the time period, the formula that we know is that T equal to capital T stands for time period. T is equal to 2 pi root over m by k. So this is what the formula we know it. Okay. Time period formula we know it. So K, here K stands for K effective. Now look at this particular diagram. Is it in series or parallel? Both the springs are in series or parallel. So let this be K1 or both are K. Okay. So here is saying identical, right? Both are K. So K1 and K2 both are equal to K only. Identical means both are having same value. So in this connection, first of all you have to identify whether it is series or parallel. Then we can find out the effective spring constant. Okay. So look this, my dear children. I can read out it in this fashion. So here there is 2 kg. Okay. So there is a spring of constant K1 and the other spring I can bring this side. So I can redraw it in this way. So K2, these both are connected. Is it clear? So now if you look carefully, this K1 and K2 right now are in parallel connection because these both ends are connected to each other and these both ends are connected to each other. So this is nothing but parallel. This is nothing but parallel combination. Okay. So during parallel combination, the effective spring constant K effective is equal to K1 plus K2. Since both are of same constants, I can write it as K and K in place of K1 and K2. So the answer will be 2K. So the effective spring constant is 2K. So look at the question, my dear children, that the spring constant value is given as 20 Newton per meter. So 2 into 20. So whose value is equal to 40 Newton per meter. So this is what is the effective spring constant. Okay. So 50% of the question in knowing the spring constant was completed. Now what about the mass? It was clearly mentioned that the mass is equal to 2 kgs. Mass m is equal to 2 kgs. So now let us substitute and see. So from this data, I am going to substitute and find out the time period. That is, T is equal to 2 pi root over m by k effective. This is what is the formula for time period. So 2 pi root over, the value for m is 2, the value for effective spring constant is 40. So what we are going to get is that by cancelling out these two, I will get 1 by 20, that is 2 pi by root 20. Okay. So let me move this 2 inside. So inside root. So what happens is that pi root over, when 2 is going inside, I can write as 4 by 20. So here it is 1 by 5. So the final answer for time period is pi root over 1 by 5 can be written as pi by 5. Okay. So the final answer is T is equal to pi by root 5. So children, now you please check out the question. Okay. Please check question. So what was given is that the time period is pi by root x and is asking us to find out what is x. Just compare these two. That is, in place of this pi by root 5, I write it as pi by root x. So now if you compare these two, what happens is that x is equal to 5. So he is asking what is the value of x. So in place of the value of x, I could write it as 5. So this question is from SHM, that is junior intern. Students, I hope you understood this. So with this, question number 22 completed.